Hi students, this is Prabhat Kumar Behra, your chemistry teacher, and we are continuing organic chemistry. In our last session, we have discussed the preparation of alkane. Okay, you must have remembered. हमें discuss करते थे preparation of alkane. So today in first session, we are going to discuss the properties of alkane. Then in second part, after the break, we'll discuss the preparation of alkene, and if time permits, then we'll go to the properties of alkene. First, properties of alkene. So, the property katha kaiba. So it will be of two types. One is physical property, another is chemical property. So first we'll discuss. One is physical property, and another is chemical property. So all of you must be knowing what is the difference between physical and chemical properties. Already lower class physical properties is ko topic like physical state, melting point, boiling point, then the solubility, dipole moment. So all these properties are coming under the physical properties. Chemical properties kona? The chemical reactions. Which type of chemical reactions are shown by the particular compound? So chemical reaction re amara asperibo, amara addition reaction, substitution reaction. Then addition reaction can be of different types. Free radical addition, electrophilic, nucleophilic, depending upon the nature of the attacking group. Okay, depending upon the nature of the attacking group. So next, oxidation reaction, reduction reaction, combustion reaction, or rearrangement reaction. So these are the reactions which may be taking place in any organic compound. Alkene, which reactions are taking place in alkene. So under the physical properties, if we'll see first physical state. Physical state. So what is the physical state of the alkene? हमें देखिए carbon 1 to carbon 4, that is methane to butane, all are gases. Then C5 to C17, liquid. And C18 onwards, all are solid. Okay, this is particularly for alkene. That is carbon 1 to carbon 4, हमें methane ru butane पर्यंत कही परिवा, those are gases. Then carbon 5 to 17 liquid and carbon 18 onwards solid. So this is first point is physical property. Then what is the second one? Second is boiling point. Second is boiling point. Then in general, any compound, it may be organic or it may be inorganic. With the increase in molecular mass, the boiling point increases. Is it clear? Okay. So, the boiling point compare kariba, suppose chloroform and CCl4. Chloroform and CCl4. Which possess more boiling point? Now, CCl4 possess more boiling point. Why? Because it has more molecular mass. Similarly, now with increase in the number of carbon atoms, the molecular mass increases, and with increase in molecular mass, boiling point also increases. That means boiling point, you can note down, increases with increase in carbon atoms. Boiling point increases with increase in number of carbon atoms. Okay. Compare kariba methane to butane. So butane has highest, then propane, then ethane, then methane. Okay. So this is first point coming under the boiling point. Next one, now this same molecular mass achi or same compound achi, jaake hum isomer kahi pariba. So in isomer, what about the boiling point? In isomer, what about the boiling point? So one of the most commonly used example C5H12. Okay, pentane. So pentane को हमें different form में लिख परिबा. This is normal pentane, iso, then neo. Normal pentane, isopentane, neopentane. So here molecular masses are same. Isomer, same molecular formula means same molecular mass. Then एक केस रे कौन हबो? Boiling point will be equal or one of the molecule will have more boiling point. अरे boiling point order कौन हबो? Equal तो बिल्कुल नहीं. ताले कौन हबो? ना boiling point is highest among these three is highest for N, then iso, then neo. Why this is so? Why this is the order? That boiling point कहाँ पर depend करची? ना surface area पर depend करची. जब हम देखिए branching जब increase होगा, with the increase in branching, the molecule becomes spherical. With increase in branching, the molecule becomes spherical. Since the molecule becomes spherical, surface area decreases. I mean, geometry, sphere is the shape which has the least surface area. If the surface area decrease होगा, ताले कौन होगा? ना Van der Waals force of attraction decrease होगा. अब Van der Waals force of attraction decrease हेले, तमरो boiling point कौन है जो? Decrease है जो. ताले इटा note करी परिबो quickly. With increase in branching, surface area decreases, and hence Van der Waals force of attraction decreases. Surface area decreases and hence Van der Waals force of attraction decreases. So boiling point decreases. Okay, noted. Next is melting point. So third, that is melting point. So in general, melting point is also directly proportional to the molecular mass. So in general, with increase in molecular mass, the melting point increases. You can note down, with increase in molecular mass, the melting point increases. But एटी टिके discrepancy अच्छी, टिके change अच्छी, कौन change अच्छी? ना जदे में एटी नबा ethane, propane, butane, and pentane. Okay, ethane, propane, butane, and pentane. जदे में एटी boiling point compare करीबा, 4 compounds अच्छी, boiling point compare करीबा. So it is 4, 3, 2, 1. So boiling point किसी भी changes नहीं, एटी किसी branching नहीं. All are normal. Okay. So all are the normal compounds. N pentane, N butane, and propane, then ethane. So the melting point order देखिबा. For these 4, so the order is 3 greater than 4, 2 greater than 3 greater than 4, then 1 greater than 2, then 1 greater than 2. तामाने में देखिए आदि, here the boiling point changes alternatively. 3, 4 भीतर exchange होची and 1, 2 भीतर भी exchange होची. Melting point exchange होची 3, 4 हवा कथा करो 4 greater than 3, but here it is 3 greater than 4. Then 2 should be greater than 1 according to the molecular mass, but here it is just reverse, that is 1 is greater than 2. तामाने जहाँ भी changes होची alternatively changes होची. So alternatively changes होची. So the name is alternation effect. Then why this is happening? जदि किसी effect हो तापर से किसी न किसी तो reason थी वो. So what is the reason? ना alternation effect पछरे reason कौन? हमें already discuss करचे geometrical isomerism रे. So geometrical isomerism देखिवा melting point और boiling point order कौन थिला? Cis isomer has more boiling point than the trans isomer. काहे कि cis isomer boiling point अधिक काहे कि थिला? ना cis isomer has more polarity. The more polarity रहिबो, it has strong dipole-dipole interaction. The strong dipole-dipole interaction थिला, ताल तरफ boiling point higher थिला. But the melting point देखिवा, माने बकाओ, trans isomer has more melting point than the cis isomer. इधर में trans isomer देखिए 2-butene कथा देखियो. Okay, so it has more melting point than the cis counterpart. Why? एठी हमें कौन एक्सप्लेन करथिले जो माने क्लास अटेंड करथिले माने थिबो. Here it has the plane of symmetry. यदि ट्रांस आइसोमर देखिबा it has plane of symmetry. यदि plane of symmetry रहला then कौन होबो ना it has better packing in the crystal lattice. Better packing crystal lattice means more melting point. यदि जमन न बुझ परछा आउट टिके डिटेल एक्सप्लेन करछि. मैं कहार भी यदि मेल्टिंग पॉइंट फाइंड आउट करबा को भी मॉलिक्यूल रो तो हाइड्रोजन रो मेल्टिंग पॉइंट फाइंड आउट करबा ता माने वी हैव टू मेक द हाइड्रोजन इनटू द सॉलिड स्टेट. तापर हम सॉलिड स्टेट देखिबा व्हाट इज द टेंपरेचर एट व्हिच द सॉलिड हाइड्रोजन इज कन्वर्टेड टू द लिक्विड हाइड्रोजन. सो दैट इज द मेल्टिंग पॉइंट. ता माने मेल्टिंग पॉइंट मींस द कंपाउंड मस्ट बी प्रेजेंट इन द सॉलिड फॉर्म. तो यदि सॉलिड फॉर्म अछि ताले सॉलिड को फॉर्म में रहबो क्रिस्टल फॉर्म में रहबो. यदि क्रिस्टल फॉर्म में रहला ताले ता पैकिंग ऊपर डिपेंड करिवो. यदि रेगुलर शेप अछि यदि रेगुलर शेप अछि ताले तार बेटर पैकिंग रहइबो क्रिस्टल लैटिस रे. जेना सपोज क्यूब नबा गोटे स्पेस रे क्यूब को अरेंज करिवो आ गोटे स्पेस रे फ्रस्टम को अरेंज करिवो. तुम जानता फ्रस्टम होचे इरेगुलर शेप आ क्यूब होचे रेगुलर शेप. सो क्यूब के हम जते क्लोजली पैक करि परिबा जते हम इफेक्टिवली पैक करि परिबा क्यूब को ता सेटा रेगुलर शेप अछि सेठी सिमेट्री अछि. फ्रस्टम सिमेट्री नाही. सो सेठी कोन हबो प्रॉपर स्पेस मेंटेन हे करो ताने पैकिंग द बेटर हो कहारो क्यूब रो. ताले मॉलिक्यूल्स एटा मन रखे इन जनरल मॉलिक्यूल्स व्हिच हैव सिमेट्री has better packing in the crystal lattice. Molecules which have symmetry has better packing in the crystal lattice. Since molecules have better packing in the crystal lattice, ताले कोन हबो ना melting point will be higher. बुझा पड़ला. तो जत्तो तमरा मॉलिक्यूल अछंती और अल्केन अछंती having even number of carbon atoms. Alkenes having even number of carbon atoms have better packing in the crystal lattice. जब crystal lattice से better packing रहेला ताले melting point भी higher रहेबो. हैला ताले जोडा में ऑर्डर लिखि थिले you can see it back. So এটা নোট कर दियो quickly. Alkenes with even number of carbon atoms have symmetry and hence better packing in the crystal lattice. So possess more melting point. Since melting point of the compounds changes alternatively so the name is alternation effect. So melting point over. Now we'll discuss next color and order. That is also color and order. देखिए lower alkenes are colorless and orderless. Gases. Colorless and orderless gases. Now the question is, हमें घरे जो LPG cylinder use करू छे. In that LPG cylinder, what is the or which are the gases present inside the LPG cylinder? So हमें देखिए it is constituting methane up to butane. All four, that is methane, ethane, propane, butane, all are present. A major component quantity, that is butane. In LPG cylinder, major component is butane. ताले हमें एठी कोन कहले these are orderless gases. कोई स्मेल नहीं. बट हम जानते LPG सिलेंडर कौन हुए ना those are Smell. Then how the smell comes? Now it is due to the presence of mercaptans. Mercaptan means sulfur containing compounds. It is due to the presence of mercaptans. କାହିଁକି mercaptan add करावे तमें ନିଜେ ଜାଣିପାରିବ ନା ଯଦି ଆମେ ସେଟା କଲରଲେସ୍ ଆଉ ଅର୍ଡରଲେସ୍ ଯଦି ହବ ଯଦି କିଛି ଗ୍ୟାସ୍ ଲିକେଜ ହବ ତ ଆମେ ତାକୁ ଆଇଡେଣ୍ଟିଫାଇ କରିପାରିବାନି ତ ଡେଫିନେଟଲି ଆକ୍ସିଡେଣ୍ଟ ହବାର ଚାନ୍ସେସ୍ ବହୁତ ଅଧିକ ହବ ସୋ ଲିକ୍ ହେଲେ ହିଁ ଆମେ ଜାଣିପାରୁଛେ ସ୍ମେଲରୁ କ'ଣ ହଉଛି ନା ଏଲପିଜି cylinder has some leakage. So ଆମେ ତ କ'ଣ କରୁଛେ we have to be extraordinarily precautious. So ଏଇଟା କ'ଣ ହେଲା ନା mercaptans add ହଉଛି in order to give the smell to the LPG cylinder to avoid the accident. ହେଲା so color and odor okay. Next ହେଲା next is ଆଉ ତମର କ'ଣ ଆସିବ ନା polarity କହିପାରିବା polarity. So these are alkenes are polar or non-polar compound. These are non-polar compound. ଆମେ ଜାଣିଛେ carbon ଆଉ hydrogen ର electronegative difference ବେଶୀ କିଛି ନାହିଁ. Since carbon ଆଉ hydrogen ର electronegative difference ବେଶୀ କିଛି ନାହିଁ ତାହେଲେ କ'ଣ ହେଲା compounds ଆମେ କ'ଣ କହିବା polar କହିବା non-polar କହିବା so compounds are non-polar. Okay. And non-polar means ଆମେ ଜାଣିଛେ like dissolves like. Non-polar compounds are soluble in non-polar solvent. Okay. Acha. So this is these are mainly the physical properties. Now come to chemical properties. Chemical properties. Student actually organic रे जब मैं सबू chapter को properly discuss न करिवा. Okay, all the chapters are interlinked with each other. तान hydrocarbon रे किछि reaction haloalkane रे पढ़िबा किछि reaction तमरा alcohol phenol ether रे पढ़िबा तो अलग अलग compound रे discuss करिवा. So तमरा किछि organic chemistry topic रही जाइथिला ताको हमें आउ हार्डली 2-3 क्लास से कंप्लीट हे जिवो so complete हला परे we will go to the 12th class organic chemistry haloalkane स्टार्ट करिवा आउ 2-3 क्लासेस आज हम डिस्कस करिवा प्रॉपर्टीज ऑफ अल्केन तापर नेक्स्ट आसीबो प्रिपरेशन ऑफ अल्केन आज आउ दीटा कि तीनटा क्लास रे हार्डली सारी जिवो हैला सो केमिकल प्रॉपर्टीज ऑफ अल्केन सो व्हिच आर द केमिकल प्रॉपर्टीज टेकिंग प्लेस इन अल्केन और इन जनरल देखिबा अल्केन्स आर saturated compound or unsaturated compound. Alkenes are definitely saturated hydrocarbons. So since saturated, so addition reaction can never be taking place. That is the first. Addition reaction haponi. How kon habo substitution reaction. So substitution reactions are of 3 types, as you know, depending upon the nature of attacking group. So attacking group tomorrow electrophile hai paribo, nucleophile hai paribo, free radical hai. Are you getting me? Attacking group can be electrophile, can be nucleophile, can be free radical. So the attacking group free radical thibo tale ame kon kehba free radical substitution reaction. Electrophile thile electrophilic substitution reaction or nucleophilic substitution reaction. So eti mainly kon habo now first thela substitution reaction. So it is of 2 types. One is free radical, another is electrophilic. One is free radical, another is electrophilic. Okay. So major kono na major reaction hela free radical substitution reaction. Second au kon hai paribo combustion reaction, then oxidation reaction, then isomerization reaction, then pyrolysis, okay, pyrolysis reaction. So these are the major reactions taking place in alkene. What are they? सबुठ जो देखियो अधिक discussion कोचरा छिवो now that is the substitution again substitution under a major hela free radical substitution reaction. Okay, substitution under major hela free radical substitution reaction. Now we are going to start free radical substitution reaction. free radical substitution reaction. Okay, so the under is halogenation. So the under is halogenation. Friend, in physical properties, if there is any doubt, let me know. Chiranjeev Das, code repeat kariba. Write the topic in chat box. Okay. So halogenation. So what is halogenation reaction? Now any hydrocarbon or alkane, we can say alkane, that is treated with halogen. Okay. So which halogen? It may be chlorine, bromine, iodine. But तापर हम देखा order of reactivity कौन आसिबो. So any hydrocarbon or alkane treated with halogen in the presence of UV light or sunlight. Okay, in the presence of sunlight or UV light to give haloalkane. ता माने आमे देखैबा CH4 plus Cl2 in the presence of sunlight or UV light. So that will give CH3Cl plus HCl if it is taken in excess. Which one? Which one? That is hydrocarbon. And if halogen is taken in excess, then all the hydrogen atoms will be substituted by halogen. Okay. So here, आपको तमे either hydrocarbon के excess से नहीं परिबो और one equivalent नबो. Then here आपको तमे halogen के excess से नउचे और chlorine के excess नउचे. So then all the hydrogen will be replaced by halogen. Okay. So this is the halogenation reaction. This is the halogenation reaction. So देखियो mechanism. Remember, any free radical mechanism takes place in 3 steps. What are those? Initiation, then propagation, then termination. Quickly note down, friend. So these are the 3 steps. एठी हमें free radical substitution ने free radical addition रे भी जोडी free radical reaction हबो. So सेठी 3 step हबो: initiation, propagation and termination. Okay, quickly note down. I'm going to see your messages. Chemical properties just हम start कर लेवे. So in chemical properties, then हम कोइले just टिके recap करछे. देखो, chemical properties can be substitution, combustion, oxidation, isomerization, pyrolysis. So these are the major chemical properties alkane रे होची. So substitution can be of 2 types. One is free radical, another is electrophilic. Our combustion reaction है पर oxidation, isomerization, आउ ये रहिला. So just हम start करछे substitution, that is free radical substitution. So under the free radical substitution, it is okay. So under the free radical substitution, it is the halogenation reaction. It is the halogenation reaction. Okay. So free radical substitution reaction goes in 3 steps. That is initiation, propagation, and termination. So we'll discuss these steps one by one. First, initiation. Okay, it is initiation. So now kon lagu initiate hobo, start hobo. So right here the reaction is initiated when halogen molecules undergo homolytic cleavage. That means equal division to form free radicals. Halogen molecules undergo homolytic cleavage to form free radicals. This is initiation. Then next, propagation. So propagation means how the reaction continues. So reaction continue केमती हबो को? The reaction continues like methane is there. It is treated with halogen free radical to form carbon free radical and hydrogen halide. Next, मन रखो जेतले halogen free radical बनिबो, so that will pick the hydrogen free radical, and जेतले carbon free radical बनिबो, that will treated or that will react with halogen to form hydrogen halide along with halogen free radical. তাহলে এটা কোন হবে? চেইন রিঅ্যাকশন চলিব, কন্টিনিউটি চলিব until all the hydrogen atoms are replaced by halogen. So CH2 एपन लेक्चर स्टूडेंट तापर नेक्स्ट पेज को जीवा आगु की जो माने चाहो जो कंटिन्यू करि परिबो सेठी कोन हबो ना CH2Cl ओके CH2Cl2 will react with Cl dot to form CHCl2 dot plus HCl तापर जेते CHCl2 dot हबो so the free radical हबो that will react with halogen to form CHCl3 plus halogen free radical ओके आपको नोट करो स्टूडेंट ये पॉइंट नोट करो देन विल कंटिन्यू I hope all of you are writing. Okay, next CH2Cl2 plus halogen free radical that will give CHCl2 dot plus HCl and CHCl2 dot plus Cl2 CHCl3 plus Cl dot CHCl3 plus Cl dot CCl3 dot plus HCl then CCl3 dot plus Cl2 CCl4 plus Cl dot. So reaction cannot proceed further kahinki there is no hydrogen left with the carbon. Okay, note down quickly. So propagation step is over. तापर कोन आसीबो रिएक्शन केमति स्टॉप होबो टर्मिनेशन आमे लिखिबो ए पर्यंत मन लेक्चर quickly note down. Then we'll discuss the termination step. I hope all of you are writing. So next step is termination. Right, this is the step in which termination. This is the step in which the reactions are terminated. The reactions are terminated when two free radicals are combined, okay, I'll repeat the student ago it has termination lecture combined to form the molecule. Here one carbon chlorine free radical is there. Our beginning re what a chlorine free radical thila. So now these two chlorine free radical can be combined to give Cl2, or एमिति परिवो one of the carbon free radical combines with the chlorine free radical to form haloalkane. That is also possible. So jodi dita free radical combine hejibe reaction se stop hejibo. So that is the termination step. Okay. So jodi student lekhithila to repeat the propagation ane mane eta complete karo. Propagation stage jo dekhiba after initiation step the propagation step takes place. In propagation the reaction will be continued. How the reaction will be continued? Now the halogen free radical vanilla initiation step re, so that will combine or that will react with the hydrocarbon. So hydrocarbon se kemti react karibo? Now it will take the hydrogen from hydrocarbon and the hydrogen undergoes homolytic cleavage. Kahinki now the halogen free radical ko hydrogen free radical milile hi so compound banai paribo. So jemti ethi dekho chlorine free radical thila, so that takes away the hydrogen free radical. So the hydrogen free radical nabo by homolytic cleavage break karike, so it carbon free radical banibo kahite HCl banila. So carbon free radical again react with halogen molecule to form the haloalkane along with the halogen free radical. So this way the reaction will be continued. So ko porjonto continue hobo na it will be continued until all the hydrogen atoms are replaced by the halogen atom. So this is the case. I think it is clear. The student lekhuthila Gadkal college or so. Okay. Student smart board re handwriting आठरो बेसी भलो करिम, बट मेति की कहि परिबी जेतो मु तुम डिक्टेट करूची सो तमे सेतल लिखि परिबो हैला. अच्छा, सो नेक्स्ट कोडा बुझेलानी. नेक्स्ट इज आमे देखिबा रिएक्टिविटी ऑफ halogen. Reactivity of halogen. So what is the order of reactor halogen? Then them कहला halogen under re it can be fluorine, chlorine, bromine and iodine. Okay, fluorine, chlorine, bromine, iodine. So what is the order of reactivity of these four halogen atoms towards the free radical substitution? Now the order is the fluorine comes highest, then chlorine, then bromine, then iodine. Fluorination, chlorination, bromination, then iodination. Okay. So fluorine is most reactive and iodine is least reactive. So ame dekhiba eti reactivity order is this. So we cannot make direct fluorination and iodination. Direct fluorination and iodination are not allowed. Why? The reason is आमे कहि परिबा fluorination is highly reactive. Note करि परिबा student, fluorination is highly reactive and makes compound even by breaking carbon-carbon bond. Fluorination is highly reactive and makes compound even by breaking carbon-carbon bond. Okay. Then next, iodination. Very slow. Iodine very slow. आज slow reaction था है, तो कौन हुए ना irreversible in nature. The slow reactions are generally reversible in nature. reversible in nature. Okay. So iodination is very slow and reversible in nature. So these are the two things or two difficulties. Straight note कर दे quick. Quick 1 minute. Okay, that's the hana किसी पिला को लिख लिया था सर हैंडराइटिंग जमा करनी कैमरा क्लियर है अबे okay student ताले में कौन कहले ना we cannot make direct fluorination, we cannot make direct iodination और रहिला कौन ना chlorination and bromination. So between chlorination and bromination, which is more reactive? Chlorination is more reactive and bromination is more selective. So that topic आमे कहि परिबो reactivity versus selectivity. Reactivity versus selectivity. Okay. So which is more reactive? Chlorination is more reactive and selectivity क्या होगा ना bromination is more selective. Okay, so you can say chlorination is more reactive and bromination is more selective. और हमें जानते हैं जे more reactive थी वो से less selective and vice versa. जे more reactive थी वो से less selective and vice versa. So chlorination is more reactive and bromination is more selective. Okay, ताले में जो देखिए आरो consequence कौन reactivity और selectivity रो consequence कौन ना reactivity selectivity consequence है ला जे more reactive थी वो so it may form the mixture of products. More reactive means it forms mixture of compounds or mixture of products. और जो more selective थी वो that will make the major product. More selective means that makes the major product. For example, हमें जो देखिए compound, let's say propane. Under or upon chlorination in propane, it makes two compounds. One is 1-chloropropane and another is 2-chloropropane. One is 1-chloropropane, another is 2-chloropropane. Or same propane upon bromination makes the product 2-bromopropane. Upon bromination makes the product 2-bromopropane. So this is the difference between the reactivity and selectivity, right? I go compound lecture. Then I will dictate. First of all, write the compound. Chlorination is more reactive. Chlorination is more reactive and hence it makes the products at all possible sites. Products at all possible sites. Next, bromination is more selective. Bromination is more selective and hence it makes the product where it is more stable. The reaction goes through the formation of free radical intermediate. So which free radical is more stable? Tertiary, then secondary, then primary. So bromination re In bromination, the product will be 3 degree, 2 degree, 1 degree. Okay. In bromination, the product will be 3 degree, 2 degree, 1 degree. Tertiary carbon achi, product will be preferentially formed at that place. Okay. So, tapare ame question dekhiba. Write down some questions. 2-methyl butane chlorination and same compound bromination. Okay. You have to write all possible products. 2,2-dimethyl propane chlorination and then bromination. So write these 4 reactions. तापर हम discuss करिबा. Note down. First, note down the question. जो माने अन्य क्वेश्चन सॉल्व करो आउ जो माने प्रीवियस पेज के मैसेज लिखिछ लिख पालनी बोली लेखो chlorination is more reactive. Chlorination is more reactive, so it forms product. So it forms product at all possible sites or positions. At all possible sites or positions. Next line. Bromination is more selective. Bromination is more selective, so forms product. So forms product mainly at the tertiary or secondary. Okay, जदि only primary carbon थिबो ताले सेठी bromination तो हबई. Now solve these 4 questions. I hope all of you are writing. Okay. Now see here how many different hydrogen atoms are present. So this is 1 and 1. Both are same. 2, 3, 4. Why 1, 1 means both are present in the same environment. And primary, the 4 be the primary. But I mean, if 4 the primary carbon achi, that is attached to secondary carbon. But 1 primary carbon is attached to tertiary carbon. ताले ठी product केते बनिबो 4 बनि जिवो. The total number of products are 4. But in case of bromination, only 1 product because tertiary hydrogen is present. That will be easily replaced by the bromine. In third and fourth, all the hydrogen atoms are आइडेंटिकल आमे कहूचे जोटा नियोपेंटेन जदि हाइड्रोजन एटम आइडेंटिकल हबो सो प्रोडक्ट कोन बनिबो गोटे ही प्रोडक्ट बनिबो ओके so in case of the identical hydrogen atoms chlorination and bromination will furnish the same product our first compound re we have not mentioned the chiral centers सेटा में ऑप्टिकल आइसोमेरिज्म अंडर देखिबा सो द माने काइरलिटी और ऑप्टिकल आइसोमेरिज्म जानथिबो सो द स्टार मार्क करछि सो दोज आर काइरल सेंटर मींस टू कंपाउंड्स हमें ऑप्टिकल आइसोमेरिज्म डिस्कस करिबा अंडर हालो अल्केन हालोअरीन चैप्टर ओके क्लियर गुड आज आउट अच्छी प्रोबेबिलिटी फैक्टर करे टर्म अच्छे जोटा में हालो अल्केन अंडर डिस्कस कर प्रोबेबिलिटी फैक्टर करके गोटे टर्म अच्छे नाउ नेक्स्ट इज combustion reaction so any hydrocarbon we can write the hydrocarbon as CXHY reacts with oxygen to form carbon dioxide and water. So how many carbon dioxide? XCO2. And how many water? Y/2 water. And how many oxygen? Now X plus Y/4 oxygen. This is the in general combustion reaction for hydrocarbon. Say tomar alkane, alkene, alkyne or aromatic hydrocarbon, any hydrocarbon. This is the in general form. CXHY plus O2 gives rise to XCO2 plus Y/2 H2O. So oxygen will be X plus Y/4. तो मैं आपको लिखिबा सपोज कार्बन 6 सहित कार्बन 6 H14 plus O2 that will give CO2 plus H2O. Put the formula. XCO2 means 6 CO2 and Y/2 H2O means 7 H2O. Then X plus Y/4. 6 plus 7. 6 plus 7 that is 13. X plus Y/4 sorry. X plus Y/4. तर हम ऑक्सीजन केते लिखियो को ना this is 12 plus 7 that is 19. So 19/2. 19/2 O2. अब तुम जानछो मोल्स लिखला बेले अबे फ्रैक्शन में भी लिख फेरे we are not writing it molecule rather we are writing in moles. Clear? Noted? Note कर दियो. So after some time we will have short break. तापर हमें ब्रेक करे स्टार्ट करियो. Next is isomerization reaction. Isomerization reaction. So what do you mean by isomerization reaction? I mean alkane kotha कहूचे. So alkanes will be converted to isomer of alkane. Alkanes will be converted to isomer of alkane. Just like if I are taking pentane will be treated with HCl and anhydrous LCl3. So that will be converted to 2-methyl butane. Generally कौन हुए ना in general 1 to shift सबुठार अधिक हुए. 1 to shift means the alkyl group is shifted to carbon number 2. Okay. और हमें नवा hexane same HCl and anhydrous LCl3. HCl and anhydrous LCl3. The product will be 2-methyl propane. So this is the isomerization reaction. Note down. and pyrolysis cracking to tome janicho. It is the process by which high temperature is given or heat is given. Pyrolysis. So upon giving the heat, the compound will be converted to the lower compound. Like suppose you are taking C8H18. Upon pyrolysis, generally the different temperature and catalyst presence हुए. So it may be converted to C4H10 and C4H8. Okay, C4H10 and C4H8. So these are the products of pyrolysis. Note down. So now we are going to take a 5 to 10 minutes break. Okay, so no need to leave the class. Jemte class re login kariki ruho. So we'll start. Okay, after 5 to 10 minutes. Welcome back, students. Friends, please do not write any personal message to each other. Okay. Now we are going to discuss the preparation of alkene. We are going to start the preparation of alkene. Okay. Now, first, from alkyne, preparation of alkene. So we'll start it from alkyne. How to prepare alkene starting from alkyne. जब हमें same reagent use करेगा, like hydrogenation method. Okay. So addition of hydrogen in the presence of palladium, platinum, or Raney nickel. Then what will happen? The reaction cannot be stopped at alkene stage. Suppose I mean, let's say then hydrogen in the presence of nickel. So the reaction will be stopped after formation of butane. After formation of butane. So in order to make the reaction to stop at the alkene stage, we have to use different set of reagents or different catalyst. Another drawback or another issue here is when the alkene will be formed. यदि हमें alkene code बनेगा, here it is but2yne. So from butane 2, if alkene will be formed, then it will be 2-butene or but2ene. So 2-butene can exhibit geometrical isomerism. It is cis trans. Now another drawback on Rayla. Now when alkene will be formed, it may show geometrical isomerism. So in order to form cis isomer, we have to use different set of reagent. In order to form trans isomer, we have to use different set of reagent. ताले cis trans ପାଇଁ को reagent use हबो आमे एबे डिस्कस करिबा. First, preparation of cis alkene. So that is known as Lindlar catalyst. That is Lindlar catalyst. Okay. So what is Lindlar catalyst? Na palladium. So I'm going to use kariba. Now it can be barium sulfate. It can be partially deactivated charcoal. Partially deactivated charcoal और palladium से तो हमें quinoline भी नहीं परिवा. Along with palladium, we can take quinoline. So कोको बुक रे calcium carbonate भी mention कराई छे. That means if we are using only palladium, the reaction will be stopped after forming alkene. Along with palladium, if we are using partially deactivated charcoal, quinoline, or barium sulfate, then the reaction will be stopped by making cis alkene. Reaction will be stopped by making cis alkene. Okay. Then what is the role of these partially deactivated charcoal, barium sulfate, or quinoline? आंको role कौन আছে? ये reaction को in between stop करछन्ती. Reaction को mid रे stop करछन्ती. यदि reaction को mid रे stop करछन्ती, ताले आंकर role कौन होची? ना to retard the reaction. ताके हम कहि परिया catalytic poison. जे reaction को slow down करे, ताना हला catalytic poison. So write down partially deactivated charcoal, quinoline, or barium sulfate quinoline or barium sulfate is used as the catalytic poison, which covers role जब पैलेडियम नौचे तार एक्टिव सरफेस एरिया को ये कवर कर दो, which covers the active surface area of the catalyst after forming cis alkene. So the reaction is okay. Palladium in the presence of partially deactivated charcoal. Carbon means partially deactivated charcoal. So this is for the cis alkene. Next is preparation of trans alkene. Okay. और मुझे ट्रांस अल्कीन बनेगा तो सेम ब्यूट 2YNA हाइड्रोजन एटीएम नवा सोडियम और लिथियम इन लिक्विड ammonia. The product will be transalkene, and this reaction is known as Borch reduction. No doubt. So over. So these are the steps to prepare alkene starting from alkyne. Next, second is from haloalkane. Now, if you are taking haloalkane, that is 2-chloropropane in the presence of base, which base you have to take? That is, the base is alcoholic KOH. Product will be propene. Okay. So it is propene. It is option nathila, but if you are taking 2-chlorobutane in the presence of alcoholic KOH, the product will be but2-ene. Okay. So here, why the product is, or the major product is but2-ene, not the but1-ene or butane. कहीं की 2-butane बनी हो, 1-butane कहीं बनी हो नहीं. Any idea, student? Why here the product is that 2-chlorobutane नौचे, the product is the 2-butane, not 1-butane. Why this is the major product? मान रखी तो formation of alkene, note down, formation of alkene is decided by Sergef rule. So Sergef ର spelling କୋଉ book ରେ ଏମିତି ଲେଖା ହେଇଛି. So ତାଙ୍କର real name is this and the English conversion is Sergef rule. So ଦିଟା ଏଇଥିପାଇଁ ମନେ ରଖ କୋଉଠି କୋଉଠି ଅଲଗା ଅଲଗା book ରେ ଅଲଗା ଅଲଗା spelling mention କରାଯାଇଛି. Right? Formation of alkene is decided by Sergef rule. So what is Sergef rule? Now Sergef rule is more the number of alkyl groups across double bonded carbon more is the stability. More the number of alkyl groups across double bonded carbon, more is the stability. So note down. How this Sergef rule is explained by which effect? Hyperconjugation effect. Sergef rule is explained by hyperconjugation effect. If you are taking 4 alkynes, then note down. So these are the 4 compounds. So what is the stability order of these 4? Actually, in first 4 alkyl groups, second 3, third and fourth 2 alkyl groups. Now what about the number of hyperconjugative hydrogen? Here it is 12 hyperconjugated hydrogen. Count kariପାରିବ. This is the alpha carbon सहित 3 and 3. Here alpha 3, but एठी कौन रहेगा? Alpha carbon से CH2 means 2 and 3. So 3, 3, 2, 8 alpha hydrogen. This is 4. This is 6. So what is the order of stability? Now so the highest take A or first, then B, then D, then C. So this is about the Sergef rule. More the number of alkyl groups or more the number of hyperconjugative hydrogen, across double bonded carbon, more is the stability of alkene. Clear? Write down. So write some questions. What are the products? Write down the products of these reactions. Quick. First compound na kono? That is 2-chloro 2-methyl butane. Second is 1-chloro 3-methyl butane. What are the products after the elimination reaction? There's a mechanism देखिवा. First step, right? Mechanism. Elimination detail हमें कुछ discuss करिवा under the haloalkane and haloarine chapter detail discuss करिवा. First है तम जदि SN1 ही परियो SN2 ही परियो. Okay. Elimination reaction is taking place at high temperature only. So let कौन होगा? The product is this. In this case, the sorry E1 of E2 over. This is E2 product. And what will be the E1 product? तो detail में discuss करिए. Okay. Now the question is, sometimes the student asks, always the product is decided by Setzer rule, or is there any discrepancy? Is there any limitation to Setzer rule? कोटी की किसी product बनी होगी, जोड़ा beyond the Setzer rule. So yes, in certain cases, the product may be formed according to the Hoffman rule. So हम लिखिए Setzer versus Hoffman product. Setzer product versus Hoffman product. Let's note down. In general, formation of alkene is decided by Setzer rule. Formation of alkene is decided by Setzer rule. Next line. But the Hoffman product can be formed in few cases. Hoffman product can be formed in few cases. So when? First, in the presence of bulky base. In the presence of bulky base. Suppose you are taking this chlorine, and in the presence of the base tertiary butoxide. Tertiary butoxide, comment लिख परियो. Tertiary butoxide. So the product will be, this is the product. Same reactant in the presence of alcoholic acid, the double bond was formed at this place at 2 position, but here the double bond is formed at position 1. Why? Right? The bulky bases like tertiary butoxide makes less substituted product as the major product. Less substituted product as the major product. Clear? Hello. Achha. So this is first case where the Huffman product is major product. Second, what is the second case? In the presence of poor living group. In the presence of poor living group. In the living group, so a living group corner. Now it is the atomer group which is released from the carbon center. It is the atomer group which is released from the carbon center in the form of anion. Shared pair of electron in the form of anion, then that is known as living group. And again, after released from the carbon center, it has to stabilize itself in the medium. Se nijku stabilize kariya darkar medium re. Bujha padla? After released from the carbon center, it has to stabilize itself in the medium. Kahinki? Now the anion ki release hala. Se nije stabilize na hobo. So it will again reverse back to the compound. It will again reverse back to the compound. Okay. So poor living group. So poor living group क्या हुआ हम कहीं पे जे compound सहित जे गोटे strong bond बनेइबो carbon सहित से गोटे poor living group होबो आ जे carbon सहित weak bond बनेइबो that is better living group. तो हम देखिए halogen case रे the living group is better is iodine, then bromine, then chlorine, then fluorine. Iodine, bromine, chlorine, fluorine. So iodine कौन होबो गोटे better living group होबो और फ्लोरीन कौन होबो गोटे poor living group होबो और weak living group होबो. बुझा पड़ला? फ्लोरीन होबो गोटे weak living group और poor living group. तले हमें जदी देखियो फ्लोरीन अछि टिके पूरा देखथिले 2 क्लोरो ब्यूटेन प्रोडक्ट कौन बनेइथिला ना प्रोडक्ट वाज ब्यू2ene. तदे हम लिखिबा 2 फ्लोरो ब्यूटेन in the presence of alcoholic KOH, the product will be but1ene or butene because fluorine is one of the poor living group. आउ ये रिएक्शन कौन कहा जाए E1CP. खाली नोट कर थाओ हमें देखो हालो अल्केन चैप्टर डिटेल डिस्कस करिबा. So this is E1CP. Elimination unimolecular in the presence of conjugate base. So this is the mechanism. Third, in case of conjugated diene. As answer conjugated diene means that will be stabilized by resonance. Suppose you have this chlorine in the presence of alcoholic KOH. This is one product. This is another product. Okay. So these are the two different products. Tell Kuo, among these two, which is the major product? So the major product is second one. This is the major product. Why? Let them देखिबा hyperconjugated hydrogen or Sedgwick rule. Here across double bonded carbon 2 plus 1. 3 alkyl groups are there. But here across double bonded carbon only 1 alkyl group is there. So Sedgwick rule will support or will favor the formation of first product. But Huffman rule is the second product. Reason कौन? हमें देखिबा Sedgwick rule is explained by the hyperconjugation effect. And here the product is stabilized, second product is stabilized due to the resonance effect. So between resonance and hyperconjugation, which is more dominating? Resonance is more dominating. Since resonance is more dominating, then product कौन बनिबो ना जेतला हमर तमरो कौन बनछि conjugated diene बनुछि, that will be the major product. Okay. So student हम तीनटा condition देखिले. गोटे कौन थिला in the presence of bulky base, second कौन थिला in the presence of poor living group, and third ela for conjugated diene. So these are the three major conditions where Huffman product is the major product, not the Sedgwick product. क्विकली नोट डाउन कर दियो तापर हम जीवा नेक्स्ट प्रिपरेशन मेथड ऑफ alkene क्विक ओनली 1 मिनिट तापर हम कंटिन्यू करिवा नोट कर दियो आ यदि इन केस कार किछि डाउट अछि you can write in the chat box. Then clear up to this? Okay. Next, dehydration of, next is dehydration of alcohol. In order to make dehydration of alcohol, we have to take the concentrated mineral acid or the dehydrating agents like alumina. Okay, alumina, and you can take calcium chloride. So these are also used as some dehydrating agent. But dehydration is mainly due to the presence of the mineral acid. Suppose we are taking butane 2-ol in the presence of dehydration. This is the elimination reaction. So elimination reaction is favorable at high temperature. Concentrated H2SO4 and heat, it forms 2-butene, again explained by the Sedgwick rule, plus water. Okay. It mechanism step kon hoche. First, abstraction of mechanism likhi the student of a proton by OH to form protonated alcohol. This is the first step. This is the protonated alcohol. Step 1. Then what is the second step? Second step, release of water to form carbocation. Okay. तामाने हम आपको यदि कंटिन्यू करिबा, this is the carbocation plus water. Release of water to form carbocation intermediate. And clear? Quickly note down. Then we'll go to the next step. And friend, always remember one thing. In any reaction, if carbocation intermediate is formed, then it may undergo rearrangement. To form more stable carbocation. Okay, to form more stable carbocation. So what will be the step 3? Rearrangement of carbocation to form more stable carbocation. So here, this is 2 degree and hydrogen is present. It makes carbocation rearrangement, hydrate shift, alkyl or phenyl shift, ring expansion and ring contraction. This is tertiary. And the last step, deprotonation to form alkene. Again, जेतबेले alkene form होबो by following the Sedgwick rule. So this, and after deprotonation, double bond is here, Sedgwick rule plus H. Hydrogen code jibo, hydrogen has to be released from this. Or when the presence of water, it will be converted to H3O plus. Okay, deprotonation to form alkene. Over, student. Now write few questions. Concentrated HCl, heat. Concentrated H2SO4 heat. Okay. So write the products. Write the products of these two compounds after dehydration. I hope all of you are trying. Make it fast. Make it fast. Last 2 minutes. Completed, student. First, we are going to discuss first question. By the action of H plus, it makes protonated alcohol. Okay. Then after release of water, this is the carbocation. Second step. Third step कौन हो? Now rearrangement of carbocation, that is methyl shift. After methyl shift, this is the carbocation intermediate. Then deprotonation to form the Z product. देख परियो, here across the double bond, 4 alkyl groups are present. Across the double bond, 4 alkyl groups are present. So this is the case. Quickly note down. Written. Any doubt in this question, student? In the first question, if you have any doubt, quickly write in the chat box. तापर हमें next question को जीवा. Okay, good. Sri Krishna. Next. स्टूडेंट देखो कार्बोकेटन रीअरेंजमेंट तुम बोर्ड एग्जाम में तो आसीबनी, स्कूल एग्जाम रे आसीबनी, बट कॉम्पिटिटिव एग्जाम पे आसीबो. So second is this. First, it will be protonated to form that is hydrated alcohol, or sorry, protonated alcohol, not hydrated, protonated alcohol. Then after releasing water, it is a carbocation, 5-membered ring, and at the alpha position, carbocation center. So ring expansion. So after ring expansion, 5-membered will be expanded to give 6-membered ring. First, you have to draw 6-membered ring and assign the numbering, and position 1 methyl group and position 2 positive charge. Position 2 positive charge. Next, hydride shift. Because this is secondary carbocation and this is tertiary carbocation. And after hydride shift, the alkene is, this is alkene. Okay, this is the alkene. As a student below pachare, how many possible alkenes are formed? Mane, before rearrangement and after rearrangement, what are the possible alkenes formed? Then possible alkene देखिबा, then हम कहि परियो from this carbocation, this is one alkene plus this is another alkene. तापर next From this carbocation, one alkene is already here, another alkene, and देखो positive charge this side alkene बनला जोटा major product में कहूचे, and other alkene can be this. Okay, এটা major product बनिबो जोटा में right side left side लिखिचे, this is the major product, but these are the possible alkenes. Question बेले बेले पचारिची competitive exam रे. So ये carbocation रो on देखिबा, this is alkene. So how many possible alkenes are there? Now 1, 2, 3, 4, 5. But major product is this, जोटा कि हमें Sedgwick rule बोली कहूचे. So quickly note down. How the छोटे method अच्छी. So after discussing the methods, we'll wind up the class. Okay. The next is from preparation of alkene only, vicinal dihalide. Then the dihalide देखिए ଗୋଟେ compounded 2 halogen atom अच्छी. So these are of two types. One is vicinal, another is geminal. So vicinal means okay. So this is vicinal, and another is geminal. और जेम और VIC वाली short form में लिखा जाए. So vicinal dihalide माने if two halogen atoms are present at the adjacent carbon atom, right? Vicinity हम कहें vicinal माने vicinity राष्ट्रीय periphery, so right? If two halogen atoms are present, at the adjacent carbon atoms, then those are named as vicinal dihalide. Those are named as vicinal dihalide. A geminal कौन? तो देखी पारती हो with the same carbon. If two halogen atoms are present, with the same carbon atom, then it is geminal dihalide. ताला vicinal dihalide को हमें तो कहाँ से treat करीबा zinc metal से treat करीबा. So it makes plus ZnCl2. Right down. I think it is clear. Up to this, it is clear. And last method left, जो generally board syllabus में नथा है, heating quaternary ammonium salt. क्वार्टरनेट बुझी पारथिबो नाइट्रोजन इज बॉन्डेड टू 4 different alkyl groups or 4 alkyl groups 4 different न कहि के 4 alkyl group पाई पर that is quaternary ammonium salt. Suppose you are taking nitrogen with nitrogen CH3 CH5 C3H7 C4H9. Okay, CH means methyl ethyl propyl butyl Cl. If you are hitting this, then it will be converted to tertiary ammonia or amine, tertiary amine, along with one alkene and HCl. One alkene and HCl. Write down. You can note down when quaternary ammonium salt is heated, quaternary ammonium salt is heated, it releases one alkene, containing the least possible number of carbon atoms. It releases alkene containing least possible number of carbon atoms along with tertiary amine. Along with tertiary amine. Okay, along with tertiary amine. Is it clear, students? Okay. Acha, outer rakhiyo. Okay. Right. When tertiary, that is 4-degree ammonium salt is heated, when 4-degree ammonium salt is heated, it releases alkene. It releases alkene containing least possible number of carbon atoms least possible number of carbon atoms. अच्छा alkene रे least possible number माने so one carbon जो डामे कोचे carbon containing one that cannot be converted to alkene का double bond हवा में minimum 2 carbon तो दरकार ठीक है जी ताले कोड स्टार्ट हबो इथिन अछि एटी इथिन बनिबो यदि कार्बन 2 नथिबो त नेक्स्ट कोन प्रोपेन बनि परिबो और ब्यूटेन बनि परिबो डिपेंड करिवो how many least number of carbon atom are there in alkyl group. अच्छा second is why this is happening एथमे होची because तमे देखि परथिबो quaternary ammonium salt means it is highly sterically hindered का नाइट्रोजन से तो चारटा अल्काइल ग्रुप अछि माने that is highly sterically hindered. So सेतमे कोन हबो ना in order to relieve the strain or in order to relieve the steric hindrance, so it is converted to or it releases one alkyl group in the form of alkene. Okay students, so I think it is clear. जो ने चार्ट बॉक्स लिखि दिलो, is it clear now? So with this preparation of alkene is over and time is also over. Yeah, you can leave the class. Next class re hame discuss kariba properties of alkene. Okay, in next class we'll discuss properties of alkene.